Hi everyone, in this video we are going to solve one problem about hydrostatic. Specifically, we are going to work with buoyancy or buoyant force and floating conditions. Okay, the statement of the exercise is this one. You receive a prism of sides 30 centimeters, 25 centimeters and 40 centimeters. Yes, a prism is a box like this one. The density of the prism is 3,500 kilograms per cubic meter, and the density of the liquid, because the idea is, it is not written here, but the idea is to submerge the object in a liquid of density 4,700 kilograms per cubic meter. Think that this density is 4.7 times the density of water. The density of the material is also denser than water in 3.5 times. And what is the idea of the exercise? To obtain the volume of the prism, obtain the mass and weight of the prism. Once you have them, obtain the buoyant force if the prism is completely submerged in the liquid, and then discuss if it floats or not, and if it is floating, find the volume submerged. Well, according to the floating conditions, something that we know from the very beginning is that this object is going to float. Why? Because we analyze the density of the material, the density of the prism, and it is lower than the density of the liquid. Okay, so we know that it floats. But we are going to justify this idea in terms of buoyant force, weight, and what happens if the object is underwater, under this liquid. Well, first step, obtain the volume of the prism. Remember that the volume depends on the shape of the object. In this case, we have a prism, so the density, the volume, is obtained as length 1 times length 2 times length 3. For the goal of this exercise, which one is L1, L2, and L3, it doesn't matter. So we can use L1 as 30, 25, or 40. But something else, we are going to use meters instead of centimeters. So the length 1 will be 0.3 meters. Okay, it's this length divided by 100. No, we pass it to meters. The same for the second length, 0.25, and the third one, 0.4. Now we are dividing each length. We divide by 100 to obtain the length in meters. So 0.3 times 0.25 times 0.4, the result is 0.03 meters times meters times meters cubic meter. That's the volume, and that's the answer of the first item. Second question, obtain the mass and the weight of the prism. Well, here we're going to use the density of the material. What is the density of the material? Density is mass divided by volume. So when we want the mass, we have to multiply density times volume. The density is 3,500 kilograms per cubic meter times the volume 0.3 cubic meter. So the mass in this case is, we calculate 0.03 times 3,500 times 3,500. The result is 105 kilograms. Okay, that's the answer of the first part of the second item. And then, now mass is amount of matter, now in physics. Weight, what is the weight? It's the gravitational force on this object that is obtained as mass times the absolute value of gravity. We can round gravity to 10 meters per second square, and in this case 105 kilograms times 10 meters per second square, we have a force of 1050 Newton. No? Remember that kilograms meter per second square is Newton, the unit Newton. Well, that's the second answer, and that's important to decide if this object it is going to float or not. Well, item C. Obtain the buoyant force if the prism is completely submerged in the liquid. here we can think that we have a pool, okay, with this strange liquid, and the prism is below the level of the free level of the liquid, no? So it's totally submerged into the liquid. But we know that it has a weight due to gravity, and when we have an object under the level or completely submerged, or even if it is floating, it also has an upwards force that we call buoyant force, because of the difference in pressure in, for example, the base of the object and the top of the object. Okay, remember that if the depth from the free level is higher, the pressure is higher. So this area is at a higher pressure than this one. Okay, so therefore we find in any object submerged into a liquid a buoyant force upwards, and this buoyant force is obtained as the density of the fluid, in this case a liquid, it could be a gas too, but in this case the liquid, gravity, and the volume submerged. Well, this order could be changed too, but doesn't matter. Density of the liquid times volume submerged times gravity. Remember that what is this? This could be thought as the mass of the liquid displaced. Now it's the mass that was before the presence of the object here and was displaced. But well, the idea of the exercise is to find the buoyant force. What is the buoyant force? The density of the liquid, volume submerged, gravity. And we receive the density of the liquid, it's here, 4,000, now it was in the list of information, the data at the beginning of the exercise, 4,700 kilograms per cubic meter, 4,700 kilograms per cubic meter, times the volume submerged, that's the volume of the object, 0.03 cubic meter, times gravity, gravitational acceleration due to gravity. So the buoyant force is kilograms. You can cancel cubic meters with cubic meters that are dividing, and kilogram meter per second squared, that's a force, therefore it's a buoyant force. And the value is 4,700 times 0.03 times 10. So the buoyant force is, if the object is completely submerged, is 1,410 Newton. Okay, that's the answer for the third item. Okay, so that's the answer for the third item. Okay, item. Well, in this case, we analyze this situation. We have the object submerged with a force upwards that is 1,410 Newton, and downwards we have a weight of 1,050 Newton. So someone maintains the object submerged, because if the object is free under the level of the liquid, the upwards force is higher than the downwards force, and the object naturally will float. Okay, so what we see is automatically it floats. So the answer is that as buoyant force is higher than the weight, it floats. Okay, so what is this idea of floating? Now we analyze a new equilibrium. So we have the pool. Okay, we have the pool here with the level of the liquid, and now the object is partially submerged. That's floating. When we analyze an object that is partially submerged, it has a part below the level of the liquid. And what happens in terms of the dynamics of the object? The object has an upwards force that is the real weight. Okay, we are going to use weight with this to mark that it's the real buoyant force and the weight. And we have an equilibrium. So you can use, for example, upwards positive, and if we sum the forces in the vertical direction, that's an equilibrium. According to the second Newton's law, sum of the forces is equal to mass times acceleration, but when the object floats, it has no acceleration. So mass times 0, 0. And if we analyze the equilibrium, we have buoyant force upwards minus weight is equal to 0. So we say that the absolute value of the buoyant force is equal to the weight. So now the real buoyant force, we know the value, is equal to the weight, that is 1050 Newton. So the question in the last item is find the volume submerged, the real one. So here we can say that we know that the buoyant force is equal to the weight in absolute value. Remember that buoyant force is not equal to the weight, because buoyant force points upwards, so it's a force that points upwards, and weight points downwards. But in absolute value, the magnitude is equal, 1050 Newton. Okay, now the buoyant force is equal to density of the liquid, gravity, and volume submerged. And this is the real volume submerged, because we know that if we submerge the whole object and we leave it there, it accelerates upwards and floats at the end. So the density of the liquid, gravity, and the real volume submerged. So we want, as to finish this exercise, the volume submerged, it will be 1050, density of the liquid 4700 kilograms per cubic meter, times gravity 10 meters per second square. No, I am dividing by these two terms. So now we have 1050 divided by 4700 divided by 10. So the real volume submerged is 0.022 cubic meters. And what about these units? Newton is kilogram times meters per second square. So you have kilogram meters per second square is Newton. You cancel Newton divided by Newton. And this cubic meter that is dividing passes multiplying. So now you have that the real volume submerged is 0.022. Something else that we can calculate is the percentage of the volume submerged, and that's the idea is, if the total volume of the object is 0.03 cubic meters, that is the 100%. What is the percentage of the volume submerged? Well, 0.022 times 100 divided by 0.03, and the result will be 0.03, 74.46 or 74.5. So 74.5 of the object is submerged. Okay, well, with this last result we finish this video. In the following video we are going to analyze problems with U-tubes and then different exercises about dynamics and hydrostatics. Okay, goodbye.